Hello and welcome to the third part of the toy train carriage series. I'll be continuing from the last episode, so if you haven't seen that yet, I would recommend checking that out. But what we did, just to recap, is if I just set this back to its previous settings, what we did was we got this railway carriage to animate nicely along this track, and it does well for the most part, except when it gets to these ridiculously tight and unrealistic bends. We can see the front wheel cage looks like it's out of position, which is quite annoying. So in this video I'm going to be showing you how to address that issue as best as I can. So yeah, if you're doing, just a side note, if you are doing a toy train carriage or if you're planning to use it for this, these bends are ridiculously tight. I mean, normally I think the carriage wouldn't even be able to navigate something like this and it would fall off. So just thought I'd throw that out there. But if you're using this for some other purpose, this solution may be quite useful. So first of all, how I'm going to structure this is that I'm going to start off with diagnosing the issue, like what's going wrong, and then I'll explain why it's going wrong, and then lastly I will show you how to fix it. So first of all, just to recap, in case you haven't seen the previous video, I'm just going to clean this up by naming things better. Put these as tag, train carriage. Yeah, okay, so this is a little easier to read. So what we have is we have this align to spline on this back wheel cage, and we're taking its position, which is in a percentage, 1%, feeding it into a range mapper and converting it into centimeters relative to the length of the track. So basically this 1% is equal to 15.473 centimeters on this track. We're then taking that measurement and adding it to the wheel cage separation, which we've set as 16.3 in this Userdata. So we're basically taking 15.473 centimeters, adding 16.3 centimeters to get 31.773 centimeters, which is the position of the front wheel cage. We're then converting that back into a percentage, so then the front wheel cage aligned to spline tag can read that as a percentage and know where to be placed. So the whole point of this setup is to make sure that there's a 16.3 centimeter distance between the back wheel cage and the front. However, as we've seen already, when we scrub to this point here, you can see it looks like the wheel cage has moved, even though there should be a consistent distance between them. So yeah, let's visualize what's going on. By that I'm going to turn a couple of nulls into locators. So we're going to get the front, and I'm going to set this as a locator, and I'm going to give it a nice red colour. Red for error. So this is the front wheel cage and we know that it's going wrong, so we're going to highlight it red. Now we're going to go into the carriage, make sure this is right, which it isn't for some reason. We get the wheel cage separation, then plug it in and halve it, because we're going relative from the back position. And then inside this I'm going to create a null. I'm going to call this where the front should be. And again, I'm going to offset a bit further, so we're in the position where it should be for the front, relative to the carriage. I'll set this to a locator, and I'm going to create a orangey yellow material. Oh, where's that gone? Oh, that's weird. Not sure why. Oh, I didn't set saturation, that's why. That really confused me for a moment there. Okay, so we've got this yellow locator, which is showing us where the wheel cage should be for the front. And then we've got this red locator, which is showing us where that wheel cage currently is. And they're intersecting, which is good. We want them to intersect because they should be in the exact same positions. But if we go into the camera and scrub through the animation, everything's nicely lined up, and then even at the first bend where it's nice and clean, you can see there's a bit of separation between those two locators. It's very minute though, so you probably wouldn't have even noticed it, and probably wouldn't even be worth addressing, to be honest, but you know, we'll address it anyway. As we continue, we get to these tight bends, and you can see the issue's becoming a lot more pronounced. There's a huge difference between where the front wheel cage currently is and where it should be. And then again at this last bend, it's very notable. You can see this is where the wheel cage should be, and this is where it currently is. So what's going on? Well, if we go into the top view, I'm just going to scrub a little bit further. There we go. Let's look at the Xpresso. So we've got 16.3 centimeters, and this red wheel cage clearly isn't at that point. So I'm just going to doodle on here. Right, we've got the back position there, and then we've got where the wheel cage currently is, and then set this to 40, where it should be. Well, slightly off the track, so I'm going to try and rotate this round based on the back anchor. So it's going to be somewhere around here. Here's where it should be roughly. You see there's a bit of a difference. First of all, we're going to check the measurement between the front wheel cage position and the back one, just to confirm the suspicions that this is the case and it's nothing to do with the carriage moving or something like that. So I'm going to expand these out a bit. I'm going to get the absolute positions of these nulls, or the global position, which is the absolute position of these nulls within 3D space. And then I'm going to get a distance node and compare the distance between these two positions. What we should get is 16.3, but what we're actually getting is 14.77. So why are we getting different values? Well, to illustrate what's going on, we have 16.3 centimeters distance between the two wheel cages along the track. So what we have here is 16.3 centimeters. Now, what we're actually getting in regards to the distance between them is, oh, that's a bit wonky. Let's try again. Close enough. 14. Oh, let's try that again. 14.77 centimeters. So what we want is this 14.77 centimeters to actually say 16.3 centimeters, because that was the whole point of this distance. We wanted it to be continuous, like a constant distance regardless of the curves on the track and things like that. So that's what we're going to be addressing. We're going to be taking this value and trying to make it this value. So how I'm going to approach doing that is, get rid of this doodle. I'm going to create a copy of this front wheel cage. I call this new front, and then the old one that we've got, I'm going to change to dummy front. So I'm going to use this to collect data to say where it's going wrong. And then I'm going to take that data and feed it into the new front with a corrected position. So inside here we don't actually need any content inside the dummy front now. It's just going to be used for reading data. The next part is I'm going to take this Xpresso tag, place it on the back, drag this to the top, because we want this to calculate first, which is feeding the information to the dummy front. So I'm just going to make sure that tag's named properly. There you go, dummy front. So just shift all this out of the way for a moment. This is what we had from the last episode, pretty much, except I've changed this to the dummy front. Then what we're going to do is get a copy of this Xpresso tag, place it on the new front. What I want to do is delete that dummy front, drag in the new front. Again, I'm going to name this new front so we know we've got the right one, and then we're going to feed this into the position. So as it currently stands, the dummy front in the Xpresso tag on the back wheel cage is being fed the exact same information as the new front in the Xpresso tag on the new front. So they should be in the exact same positions. And if we were to turn off the dummy, well actually I'm going to set the new front to a green colour so we can see a difference. Okay, so we can see the new front's there, and if we hide that, we can see the dummy front there. There's the old one. Okay. Now I'm going to go into the old Xpresso tag and keep it as it was, nice and clean, get rid of all that extra stuff if I can. For some reason I couldn't delete. There we go. So this is the same as what we had before, but with the dummy front there. And then in the new front, what we're going to do is keep this set up and bring these back, because we're going to be using this information here, so we're going to need this. Just to quickly clean up further, we need to make sure this PSR carriage is aiming at the new front, because at the moment it's looking at the old position, which is not what we want to be using anymore. Okay, and I'm going to scrub back to the start. Oh, just noticed there's a bit of delay in something there, so I need to address some of the order of operation, I think. Let's see. Go to the next frame, scrub through a bit. Oh, yeah, okay. So there's two issues here. And the first one, which, because I've already done this before, shift those. There you go. Order of operation works better in this way. And then you can see there's still a bit of snapping. That is due to the aim constraint having the wrong priority order. So I'm just going to crank that up a bit. If we go back, yep, there's no delay there anymore. Okay, sweet. And as you can see, we've got the green position close to the yellow. Nothing's been corrected yet, so this should be the same as when we had the red one. So if we turn off the new dummy, we've still got the old one in the exact same position. So we've not fixed anything yet. However, if I climb back out of this camera, so you can see what I'm doing, I'll start getting to work on fixing it. So we'll go into the new front Xpresso tag. What we want to do is, let's just go to the problematic part actually, just so it's a lot more evident when we're making changes. There we go, nice big distance there. What we want to do is take that wheel cage separation value that we want and subtract the vector distance that we're getting between those 2 points, which will give us a small number which is basically showing us how much we need to correct the distance by, roughly. Then what do we need to do then? Think. We need to add this result to the back position in centimeters So now this math node here is the back position with this correction added, and then feed that into this math node, as you can see it just snapped, which is including the wheel cage separation. So basically, I mean, I could reorder this so it's a bit cleaner. So I'm going to put that back, so you can see things went all weird there. And I'm going to feed this one into here, just so it makes a bit more sense when you come to reading it. So what we have is the back position in centimeters fed into this math node with the wheel cage separation of 16.3, which is where the green locator currently is. But then we're going to take that, add this offset to this range mapper node, which will then convert that into a percentage to the align to spline. And as you can see, it's a lot closer. It's not like perfectly in place, but it is a lot closer. And when you scrub through, I'll just show you what it looks like at the moment. We'll refine it further, but where is it? Where's the camera? There we go. So if I go from the start and we scrub through, so we've got the red locator, which is showing us the old position, and as you can see, the green one is pretty much sat inside the yellow one, just so you know it's not sat inside the red one. There you go. So I'm going to carry on scrubbing through. So it's already made a massive difference on the first bend. Then when we get to this bend here, much better. Again, we're getting a small difference in distance there, but it's nothing too extreme. And if you do want to correct it, we'll get around to that in a moment. And then again here, however, actually do need to be careful with perspective here, because it did look like the red one was in a better position, but as you can see, the distance here is much better. So I'm just going to go back to the previous bends just to make sure. As you can see that the green is pretty much lined in with the yellow one, so I'm quite happy with that. And again, going back on these bends, this bend here, we can see the green is pretty much inside the yellow locator, so I'm quite happy with that. So we'll get to the problematic part again. I'm going to hide the old dummy because we don't need that anymore, at least not visibly anyway. What we're going to do now to further improve this is introduce some manual intervention, because I did have something a lot more refined, but it turned out it was bespoke to this specific carriage. I started doing some various tests with it and noticed that if I extend the length of the carriage, this issue becomes a lot more pronounced, and my previous rig wasn't accommodated for that either, so I've built this setup. But yeah, you may need to do some manual adjustments on the very, very tight corners, or if your carriage is incredibly long. So yeah, let's try and address that. First of all, actually, I'm gonna set up a bit of data so we can drive the animation with this rather than using the align to spline tag on the back wheel cage. Just makes it a little bit cleaner. So if I can make this a bit bigger, then we want front wheel cage manual correction. Okay, I'm going to set this step to 0.01% because I've done this before and you need to use very minuscule values. I'm going to turn off the minimum and maximum because we want to be able to offset forwards and backwards, and we don't want to be limited by how far we need to offset. Okay, and as soon as I've just done that, I've just realised there's an issue. I'll keep it as it is, and I'll show you the issue later on actually. It won't be apparent, but it'll be when we start keyframing things, that's when the issue will occur. So first of all, want to open the original Xpresso tag, and then go into here and place the driver. what we're going to do is have this feed, oh, if I can just zoom in, there we go. We get the driver to feed into the align to spline back. So this will be driving the position of this. So in order to do that, we want to copy this track, paste it onto this driver, which is not plugged into anything yet, so it's not doing anything. Then I'm going to go back to this tag, delete the animation. So this is no longer animating now. And then just be a case of plugging the driver into the position. Now nothing should change. There we go. And when we scrub through, the animation should still be there, except it's no longer being animated with this, it's being animated with this. So if I shift it forward, shift it back, it's still animating. It's just a lot cleaner to be able to just click the train, or the train carriage, and animate it here. Now for the front, the front wheel cage correction thing, to fix this, I'm going to go into the Xpresso tag for that and find the front wheel cage manual correction. Now I've kept this as a percentage for a couple of reasons. One, it means we can just simply plug it into the very end. We're going to add whatever sum we have here to the result of this calculation. So we're going to take the last part of the calculation and add this value to it, which happens to be in a percentage, because it needs to be in a percentage for the align to spline tag to read it. So that's good. The other thing is, it also, keeping it as a percentage means that we can change the length of the track and things like that, and these values will still uphold. Because if we had these as centimeters, 1 centimeter on one length of spline could be massively different relative to another one. So just to keep things procedural, basically. So what we're going to do is get an add node and plug the final calculation into here, and then add the manual correction to it. Now again, nothing should change when we plug this in. Everything's great. However, when we start adding to this, you can see we're able to move this into a better position, and then when things are normal again, we can just undo it. So you can see where I'm going with this. What we're going to do is, for the sake of this example, I'm just going to keyframe here, then scrub back a bit to where it's really problematic. Actually no, I'm going to go to that looks good, that doesn't, so I'm going to put a keyframe here. Then we're going to go to this one and increase it slightly. Now you can go through this and fine tune as much as you want, but I'm just going to do this nice and quickly. Good enough for me. And then increase it a bit more. No, decrease it. That's a painful value. Okay, say 6, 7, something like that. Okay. So there we go. I apologise that I've had to rely on manual intervention for this, but it's such a unique scenario in which you'd need something like this, and I don't think it'd normally be physically possible anyway, so there's going to be some caveats for this kind of thing. Plus, by doing this, you're able to amend it as you feel necessary. I don't think I'd be able to come up with an automated solution for every possible curvature in the track and length of carriage, especially if it's like a wiggly road or something like that within a short space. It's going to be hell to calculate that. So with something like this, you've got a bit of manual control. So that's all good. Now, the reason I was hesitant on putting this in the user data wasn't because of its functionality, it's because of these keyframes. Now, I'm not sure if you can see, I've got the first frame here, which is actually of this parameter. However, it's also being displayed in the timeline with the keyframes I've set for this parameter. I don't like that. So what I'm going to do is I'm going to create Userdata tag and then just repeat what I did before, which was front wheel cage manual correction. Turn these limits off. I'm going to say 0.0001 because as we found, those minuscule values before weren't even small enough. So now we have this, and it's just a case of dragging this tag in, get that user data we made, plug that into the math node which this one's being fed into, which is here, and then remove the old port because you don't need that anymore. Going to here, I'm going to copy the track, then paste the track, and then where is it again? Yeah, I'm going to delete the track in this one and then just delete the data altogether. Remove. There we go. So now this tag's plugged in, it's got the keyframes from before set here. However, if I just select this tag without selecting this null, you can see there aren't any keyframes at start or end of this timeline for the driver. However, if I just click on this null, we now just have the keyframes for the driver, so it just keeps those keyframes separate and it makes it a lot easier to manage. So now when we scrub through, everything's nice and clean. So I'm hoping this helped. Also not as elegant a solution as I was intending to propose, but in the end with this manual intervention I've actually got much more precision than I was getting before, so I'm actually quite happy with how this turned out. Again, even without this manual adjustment, it's much better than it was before, because if we see where it was before, it was a lot worse. So yeah, again, hope this helps. If you have any questions or if you have any other alternatives or solutions or any propositions as to how this can be improved, I'd be happy to hear them. Feel free to put them in the comments so we can all see what input you have. Again, feedback's appreciated. If you enjoyed this series, let me know. Actually, I'll do a bonus video at the end of this in which we can get the wheels turning. I'll do a separate video for that because this one's probably already too long and it has broader applications beyond the scope of this video, so I'll cover wheel rotations next. Yeah, so if you're interested in that, stick around and hopefully see you in the next one.